Okay, so now we kind of get it. We're doing a hypothesis. We're going to collect evidence. We're going to look at a p-value and a thing called an alpha, right? No, but we're going to use in these next examples all the components and just make conclusions. So we're just going to make a decision, a conclusion, and probably interpret the results. All that first preliminary work is going to be done. We're just kind of here to kind of see what the significance of the p-value and make a conclusion. All right, so let's look at example 9.6. So it's a boy genetics lab claim their procedures improve the chances of a boy being born. The results for a test of a single population proportion are as follows. So here they're saying the null hypothesis is the population proportion is 50%, right? 0.5. This is status quo. It's saying, hey, if you get pregnant or if a family chooses to get pregnant, that chance is 50-50. That's just status quo. But with science today, like this boy's genetic lab says, well, you know what? We claim that I can make your chances better. And so they're claiming that the proportion is more than 50%, right? That probability. Okay, we can give you a better probability. We can make it 70% chance you're going to have a boy if you come to our lab, right? So the probability of rejecting the null when we shouldn't is alpha, right? So this is the alpha, which is 0.01 or 1%. You probably recognized it from chapter 8 in confidence intervals, right? And the p-value, after conducting all the tests and analyzing the data, they found the p-value to be 0.025. Let's go ahead and um, draw the figure, determine whether the result is statistically significant, and we can interpret the results. So in this case, our population parameter is 50%, right, or 50. So that's our p, which is 0.5. And the p-value is 0.025, right, the area on the right, so 0.025. Okay, and so now what we need to determine is where is the alpha in this case? So we did the p-value. Here's the p-value. Let's go ahead and determine the alpha. All right, where is the alpha? If we compare decimals 0.025 and 0.01, we could see that alpha is somewhere in here, right? And let me go ahead and write that, right? So alpha is 0.01, which is in here. So now let's go ahead and take a look. So if the p-value is equal to 0.025 and the alpha is equal to 0.01, now we look at comparing these decimals, and we could see that the p-value is greater than the alpha, meaning that if I randomly took another sample, the probability of getting the same results is greater than making a type 1 error, meaning that there's just not enough to make change and that we should keep status quo. So therefore, we do not reject the null. Okay, so that's the first part that we would do. The second part, we would answer this question. Now that we see that the probability for the p-value is larger than the alpha and we do not reject the null, we could say that this result is not statistically significant. Okay. And so then now what we can do is now interpret and see what this means. So don't forget that we were trying to test that It's a Boy genetics lab. Remember, their claim was like, hey, I can get you better results. The probability of having a boy if you come to our lab is greater than 50%. Well, after some analysis, we realized that there's just not enough evidence to support that claim. So if we do not reject the null, right, we have to reject the claim because we are not rejecting the null. What does this mean? We could say that there is not enough evidence to support the lab improving chances of having a boy. Okay, so that's kind of the thought process. Like we're going to have a few steps before 1i where we compare the p-value, but essentially we're going to just be given a claim. We're going to do this stuff by ourselves, draw it, and then do the rest of the process. So let's try one more now. I believe the next one will be a mean. So we're going to do proportion and mean. So, okay. So example 9.7 states that the administrator at a local hospital states that on weekends, the average wait time for emergency room visits is 10 minutes. Based on discussions on the length of wait time to be seen in the ER over the weekend, an employee disputes the administrator's claim. The employee decides to test his hypothesis. Over the course of a few weekends, the employee records the wait time for 40 randomly selected patients. The average wait time for these 40 patients is 11 minutes with a standard deviation of 3 minutes. Does the employee have enough evidence to support his claim that the average ER wait time exceeds 10 minutes? He tests at a 5% significant level. If the null hypothesis is not rejected, what is the employee's conclusion? Okay, so there's a lot here. So let's go ahead and try to put this together now. So here, so the first thing we need to discuss is the preliminary, right? So the preliminary that we have is going to be about a mean. And so the first thing we need to discuss is that n equals to 40 is no more than 5% of all patients at the hospital. And yeah, we can assume definitely that 40 is much less than probably all the patients in the emergency room in the hospital. And then number 2 is n equal to 40. It has to be greater than or equal to 30. And so that's obviously true. And so we're okay with the preliminary. So now what we can do is go ahead and move on to the problem. So let's go ahead and now conduct the hypothesis test. So again, we want to be able to determine the parameter. We determine it's a mean. Why do we determine it's a mean? Because they told us it was a mean with standard deviation. If they don't give us a mean or standard deviation, we automatically defer to proportion. Okay, so the first step in hypothesis test is always to determine what is the hypothesis, right? So the first one is the status quo. So status quo says that population mean wait time in an emergency room is just 10 minutes, right? So that's status quo. We said, no, no, no. Status quo, 10 minutes. In the alternative, is going to be the mean, and we have to see what the language is in the claim. So, based on discussions of length of wait time, an employee disputes the administrator's claim. He decides to test the hypothesis. Over the course of a few weekends, he records the wait time for 40 patients. So his claim is that the average ER wait time exceeds 10 minutes, meaning patients are waiting longer than 10 minutes in the ER. He doesn't believe what the administrator is saying. So exceeds, and this is time where we use our labs, right? Right? Exceeds means more than the status quo, which was 10 minutes. And mark that it's the claim as well. So put a little C like I do. The second part is going to be identifying the alpha, right? So the alpha is given to us at a 0.05, or in other words, 5% level of significance. The third part is now going to determine, is it statistically significant, right? Is there enough evidence to support the claim? Right? Do we reject or not reject the null? Okay, so let's go ahead and draw now. Let's go ahead and draw it on the figure. So what I did already is I put 10 minutes in the mean, and then I took the standard deviation with respect to the sampling distribution as 11 over the square root of 40. And I just wanted to add and subtract it 3 times so it looked nice. And so really, if the alpha is 5%, right, so it would be, here we go. Let me go ahead and mark it for you. So here's alpha, which is 0.05. And so because we're doing a mean, this would be a t distribution, right? T sub alpha. And so what they gave us in the very last statement was if the null hypothesis is not rejected. So what does this mean? So if the p-value was some value and alpha is 0.05, in order to not reject the null, that means there couldn't have been enough evidence to support the alternative, right? And therefore the p-value is somewhere, I don't know what it is, but I know it's larger than the alpha. And this means that, is it statistically significant? No. Right? Why no? Because we do not reject the null. And if we do not reject the null, that means we keep it status quo and we have to reject the other. Please use this technique. It will help when interpreting your results. Because next, we will interpret. So we just don't say, oh, we reject the null, not reject. That's scientific. That is a robot. And so we want to just talk about it in a conversation. So what would you say after, you're sitting in a meeting? What would you say about the administrator's wait time versus what the employee disputes? Right. So we would just say that, I would just say if I was in a meeting, well, there wasn't enough evidence to show or to support the claim that the wait time in the ER is longer than 10 minutes.